Good morning. Today we are going to discuss the simple harmonic motion, the superposition principle of simple harmonic motion in two dimension. So how the two waves superimpose together, which are simple harmonic in nature. So let us start with the understanding of superposition principle. Then we will formulate this derivation. Now this principle states that when the two waves of same amplitude or different frequencies they superimpose upon each other, so what happens? So let us say y1 is the displacement, y2 is the displacement. So what happens? The resultant displacement will be get added up, and so the net displacement will be equal to y1 plus y2. So that is the basic superposition principle which is being there. So that means they waves superimpose each other, means there is an interference which is going to take place, either the constructive or destructive, depending on whether they are in the same phase or in the opposite phase. If they are in the same phase, then the constructive interference. If they are in the opposite phase, then the destructive interference. Now let us start with the two simple harmonic waves producing a displacement of particle along the same line. Let us begin the case when both the waves have the same frequency. Consider y1 is the wave having signal y1 is equal to a1 sine omega t, and let us say initial phase is equal to 0. Second wave is equal to a2 sine of omega t plus phi. Let us say phi is the phase which is different from the first wave. So that means phi is also called as the phase difference, because it is the difference between the phase of the two waves. So that means here it is 0, here it is phi, so phi minus 0 is phi. So that means phi is also called as the phase difference between the two waves. Now what is the resultant displacement? Resultant displacement will be equal to y is equal to y1 plus y2. Now put this value of y1 is equal to a1 sine omega t plus a2 sine of omega t plus phi. So this is the equation. Now this equation can be resolved by these different parts. One is if the amplitude is same, or if the amplitudes are not same, how the superposition takes place. Let us discuss all this by one. Now case 1. Now let us take the case 1. Now we have find the equation y is equal to a1 sine of omega t plus a2 sine of omega t plus phi. So this was the wave. Now let us say case 1 is a1 is equal to a2 is equal to a. So what will be the y? Y is equal to a sine of omega t plus a sine of omega t plus phi. Now this topic is important because this topic, the theory of this topic is very rarely available in certain books, and in detail the derivations has not been given. So you have to follow strictly this derivation as a notes for yourself. So now we will take it as a common sine of omega t plus sine of omega t plus phi. If anything is not clear in this derivation, you can able to ask me again after the video will be over. Now it will be sine c plus sine d. Now we know that there is a formula for sine c plus sine d is equal to 2 sine c plus d by 2 into cos c minus d by 2. So this part omega t is called c, this omega t plus phi is called as d. Now we will get the value y is equal to 2a sine of omega t plus phi divided by 2. So that is the first part. Then the cos of omega t minus phi divided by the 2. So that is the second part. Now we can replace it at 2a sine of omega t, 2 omega t by 2, that is this one, plus phi by 2. And then here it will be this omega t will be get cancelled, so that means minus phi by 2. That is the second part will remain. Now we can separate it out, that is equal to sine of omega t plus phi by 2 and cos of phi by 2. So that means when the two waves of same amplitude interfere with each other, so the original wave plus some second wave will be come out to be there, which depend upon the phase of the phase difference of the second wave. So that is when the two waves of same amplitude they are going to get combined. So that means almost same simple harmonic wave is going to be get formed. So that was the case 1. Now in the second case, so we have started from this equation. Now case 2, when the amplitudes are different, means a1 is not equal to A2. So they are not equal. So we will write it as A1 sine omega t plus A2 sine of omega t plus phi. Now we have to solve these equations. How to solve them? Now to solve them, we have to solve this factor sine of omega t plus phi. Now what is sine c plus sine d? It is sine a plus b, sine a cos b, sine a cos b plus cos a sine b, cos omega t sine phi. So that means this is the interpretation of this one. So this value we are going to substitute over here. So what we will get, y will be equal to a1 sine omega t plus a2 of sine omega t cos phi plus cos omega t sin phi. So that is the part which is going to be there. So that is the second part. Now we can collect the simple part, omega t plus a2 sin omega t cos phi plus a2 cos omega t sin phi. Now what we will do some calculations here. How to do that? We collect these two factors together. So that means a1 plus a2 cos phi into sin omega t plus a2 sin phi into cos omega t. So that means either in the form of sine or cosine we will write it out. And then we will substitute, let a1 plus a2 cos phi is equal to r cos theta, and a2 sin phi is equal to r sin theta. Now when you put this value, so this y will become equal to r cos theta sin omega t plus r sin theta sin theta cos omega t. So that means r is the resultant of amplitude, so that we will get it out. So sin omega t cos theta and plus cos omega t sin theta. So that is a wave. So that means cos sine a plus b, it will be sine of omega t plus theta. So again we have seen that the resultant wave which is formed, it is always a simple harmonic wave, that is a simple harmonic. Now we are going to find the value of r as well as theta. So that is using 1 and 2. To get the value of r, what we have to do, we have to eliminate theta, which can be done by scaling and adding. So by scaling and adding, we can eliminate the value of r. So what was that? a1 plus a2 cos phi was equal to r cos theta, and a2 sin phi is equal to r sin theta. So that was this one. Now scaling and adding. So scaling and adding, what we will do, a2 cos phi whole square plus a2 sin phi whole square is equal to r square cos square theta plus r square sin square theta. So that this will be there. So that means right side you will get it out, cos square plus sin square. So that is the simple value. That means it will be equal to r square. So this value will comes out to be r square. Now we will get to this one, a1 plus a2 cos phi whole square. So that will be equal to a1 square plus a2 square cos square phi plus twice a1 a2 cos phi. So that is the first part. Now this second part is consists of a2 sin phi. So that you can write it as a2 square sin square phi. So that means this you are getting it out. Now a2 square value will be collected. So again it will be a1 square plus a2 square plus 2a1 a2 cos phi. So that is equal to the r square, or the value of r is equal to, so the resultant amplitude will be equal to a1 square plus a2 square plus 2a1 a2 cos of phi. So that means when the two waves of different amplitude to superimpose upon each other, so they will form simple harmonic wave, and having the resultant is coming out to be of this form. Now that means this resultant value will be dependent upon the phi. Now let us say special cases. Case 1, case A, when phi is equal to 0. Now when phi is equal to 0, cos phi is 1, because cos 0 is 1. So r will be equal to under root of a1 square plus a2 square plus 2a1 a2 this one. So that means it will be equal to a1 plus a2 whole square. So that means equal to a1 plus a2. So that means when the two waves of a zero phase difference, they merge together, the resultant amplitude will be equal to a1 plus a2. Whatever the individual wave and the second wave, they will be clubbed together and form the resultant wave. Now, when the next part is when phi is equal to 90 degree. When the phi is 90 degree, so r will be equal to cos 90 is 0, so it will be a1 square plus a2 square. So that means the resultant will be equal to square of amplitude of 1 plus square of amplitude of second. So that is the second part. Now the third case is we can able to find it out. Let us find out the third case. Now the third case is when phi is equal to 180 degree, so r is equal to under root of r is equal to 180 degree means out of phase. So a1 square plus a2 square plus 2a1 a2 cos 180. Cos 180 is minus 1, so it will be equal to under root of a1 square plus a2 square minus 2a1 a2. So that means equal to under root of a1 minus a2 whole square, so which is equal to a1 minus a2. So means when the two waves of opposite phase they superimpose upon each other, so that there will be the phase difference of that means the resultant amplitude will be subtracted from each other. So that means the minus of that sign will be there. So that was all about the superposition of two waves along one direction having same amplitude, having different amplitude, what kind of waves amplitude of superposition are going to take place. We are going to apply, this is on the LC oscillation circuit. Let us start with this one. This is an LC circuit, how the LC oscillations are going to be started. So LC circuit consists of two types. One is called as inductor, another is called as capacitor. So capacitor used to charge the capacitor used to get charged and discharged, and inductor used to get magnetized or demagnetized upon EMF, because EMF, whenever there is a change of EMF, rate of change of current is there, EMF is induced into it, which produces a magnetism. So that means it is used to store the magnetic energy, it is used to store the electric energy. After once the capacitor get fully charged, it get full electrostatic energy, and when it get fully maximum current is passing through it, so that means it gets maximum magnetic energy. So what happens when they are connected together and a supply is given to them? So that means the oscillations are going to take place. So basically that oscillations are going to be in this form, that is this one. That is called as simple harmonic waves, and they are should be constant in nature. That means with constant phase and all, they are should be regular waves to be there. But these waves should be these are the actual, should be actual, real, but practically these kind of waves are not to be there, because there are certain reasons for it. Now what are the reasons for it? So let us state when the initially state capacitor is fully charged and there is no current is there. So that means there is zero magnetic energy is zero. It has the maximum current is maximum electrostatic energy is there. As soon as it is discharged, current starts flowing to be there. So whenever the current is flowing, so the change of current will cause EMF to be induced, which cause the magnetism to be set up inside it. So that means magnetism is going to be get magnetized slowly. So that means the slowly and slowly at one stage, so it will be get half magnetized, half charge will be remained, and once this will be get fully discharged, so it will be get fully magnetized. So now once it get fully magnetized means it has got maximum energy. After that it starts losing its energy, and the capacitor is going to get charged. So that means its energy starts going on decreasing and its capacity is going to be increased. So once this energy decreases, its capacity will be increases. So this process is going on simultaneously, which produces the oscillation inside the circuit. So these kind of oscillations are like this way. So such kind of oscillations are being produced inside the circuit. So now these oscillations are get damped oscillation practically, because practically what happens during the decay of energy, during that charging and discharging, some amount of energy is going to get lost during the heating process. So due to that, the actual oscillations should be this one, but practically the oscillations comes out to be decreased, and at one particular stage these oscillations get decayed. So that's how LC oscillations are going to be correlated with SHM. Now we know that Q by C is the charge, Q by C is the potential across the capacitor, and EMF, the voltage across the inductor, will be this one. So Q by C is equal to L into di by dt, or I is equal to minus dq by dt, because rate of change of current is decreasing dt. So we can write it as, let me go further, I is equal to minus dq by dt. So we can write it as Q by C is equal to minus L into d2 q by dt square, or Q by C LC plus d2 q by dt square is equal to 0, or d2 q by dt square plus omega square q is equal to 0, where omega square is, so this is the equation of simple harmonic wave. So that means omega square is equal to 1 by LC, or omega is equal to 1 by under root of LC, and omega is 2 pi f. So that means 1 by under root of LC, and frequency comes out to be 1 by 2 pi under root of LC. So that is the frequency of the oscillation which takes place in the LC circuit. So this was all about the next topic, superposition and the LC oscillation. Thank you.